Okay, we're going to solve derivative. But before we start solving derivative, let's understand what derivative is about. So let's take a well-known example. When we're driving car, we can put on a cruise, right? So when we put on the cruise, then the speed is gonna be constant, correct? But at the second I take cruise off, the speed is gonna be different. It's gonna be instantaneous speed, right? At any given time, it's gonna be different. So how to find the speed in that case? To answer that question, we will take first derivative of the position of the car. Now, but if our speed is a function of time, then on the top of the speed we will get velocity. The first derivative will give us velocity. What is the difference between speed and velocity? Speed is a scalar value. Velocity is a vector, meaning it's a scalar value plus direction, right? So if I am driving with the speed 5 miles per hour, let's say. So, but the velocity will give me which direction, one direction or another direction with a given sign, positive or negative. Okay, so velocity is a vector, which means it has a scalar value and direction. Speed is just a scalar value. All right. And what if we take one more derivative from the first derivative? If I take another derivative, then second derivative, let me write down. So first derivative it's gonna give me velocity. Besides of my explanation, velocity we can take as a rate of change of the position. Rate of change of position. Okay? Second derivative, if I take one more derivative, it's going to give me acceleration. Okay, acceleration is going to be rate of change of the velocity. Now, because I'm going to take derivative of the velocity, that's why it's going to be a rate of change of velocity, which will give me acceleration. If I take another derivative, third derivative, it's gonna give us jerk or surge in electricity large. Okay, and that's gonna be rate of change of correct acceleration. Acceleration. And the fourth derivative, and I won't go any further, fourth derivative, it's going to give us Jones. Or snap. And that's going to be rate of change. Yes, you already know. change of jerk. Okay, that's good enough. All right. Now, since we understand what is what, now let's figure out how we are going to take derivative. So first of all, let's get familiar with the notation of derivative. Notations of derivative are as follows. D as of derivative by dx. So derivative of y by x. This is first notation. Or we can write down dy by dx. Or we can put, if it's function, we can put f prime of x, this prime meaning derivative. Or if it's only y, we can put as a y prime. Okay? So either one, they are the replaceable. It's just there is the difference. Meaning is absolutely the same. It's just in some cases it's more convenient to use one notation. In another case, it's convenient to use another notation. For example, let's say if I have y is equal whatever 3x plus 5, then to find derivative, it's convenient for me to put y prime because I don't have y of x. But if I have f of x is equal blah 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 blah, then I put f prime of x, correct? Or if I have y, I can put dy by dx. Either way. Okay, it's just a matter of convenience, that's all. All right, so let's learn very first the rule. So I'm going to cover basic derivatives, basic rules for derivatives. Okay, first it's going to be derivative of a function using constant rule. Constant rule. Let me write down here. Constant rule says if you take derivative of constant by x, it's going to be equal 0. A little bit later, you will understand why. I will go over, explain. And meaning-wise also, I can tell you that because constant doesn't have any inference with x, that's why it's 0. And we are taking derivative by x, based on x. That's why constant is equal 0, because it has nothing to do with x, it's a constant, while x is a variable. So let's see by example. So first example, if I have y is equal 6, see I have 6, it's a constant. And there is no x at all. So from here I can write down dy by dx, which means derivative of y, is going to be 6. Or I can write down this way, derivative of 6, like this, by dx is equal 0. Another example for constant rule, f of x is equal 0. And f prime of x is equal 0. All right? Number 3. We are dealing with constant. S of t is equal 0. We can write down s prime of t is equal 0. Or I can take, let me take it different, something different. I'll take it 4. Prime is, it's going to be s prime, which is derivative. It's still going to be 0, right? And one more, number 4. Y is equal 4 pi squared. Then I can put y prime is equal how much? 0. Why? Because 4 is a constant. Pi is also a constant, right? All right. Next, we are going to use power rule. For the power rule, we take derivative by x for x to power n is going to be equal n times x n minus 1, which means this n, x to power n, this n will come in front, and the exponent will stay less by 1. Okay, so let's solve a couple of problems. So let's assume we take derivative for x. So I can write down x to its power 1, right? Put prime here. So that means this one will come in front, x 1 minus 1, right? The exponent going to be less 1, which is going to be 0, and it's going to be only 1. Okay? Now, I told you in a minute, a little bit later, I'll explain why the constant is equal 0. Let's use power rule for constant. So if I take dx for constant, what, 5, right? So, or 5 prime. This is, I can represent 5 as 5x to power 0, right? Because x to power 0 is 1, so it's the same 5. And what is going to happen? 5, constant stays the way it is, so it's going to be 5. And x to power 0, derivative for x to power 0, 0 come in front. And in exponent will be less 1, 0 minus 1, going to be negative 1. So at this point, what do we have? 5 times 0, x times x to negative 1. We don't care what is in surrounding as long as there is 0, that's it. It will wipe down everything to 0. This is why when you have constant, it's going to be equal 0. Okay. Next example, f of x is equal x to power 4. So that means derivative f prime of x is going to be equal, 4 comes in front, right? X, and the exponent will be less by 1, which is going to be 3. Okay? Another example, g of x is equal cubic radical of x. So I'm going to write down g prime of x is equal derivative by x writing down in the form of rational exponent. Whoever doesn't know how to work with rational exponent, look for by topic playlist where we have exponents there. Okay, x to power 1/3. that means we are going to have 1/3 will come in front, right? And we will have x to power 1/3 minus 1, right? That is going to be 1/3 x to power negative 2/3. Yes? Which means 1/3 x to power 2/3. Because it's negative exponent. What's the rule of negative exponents? A to power negative m is equal 1/a to power positive m, right? And that will bring the whole exponent down. Okay, and the last one, y is equal 1/x squared. So from here, derivative dy by dx, I am writing down, instead of 1/x squared, I'm writing down x to power negative 2. Okay? The vice versa. Representing in the format of negative exponent. This is going to be negative 2 come in front, x to power negative 2 minus 1, going to be negative 3. And that means negative 2/x cubed, using this property of exponent. Yes? All right. Now let's use constant multiple rule. Constant multiple rule. Okay. This rule says d of c f of x, where c is constant obviously, by dx is equal c f prime of x. Okay? Example. Y is equal 5x cubed, which means 5 stays, right? And we are taking derivative of x cubed. Yes? Derivative of x cubed. And that is going to be equal, let me rewrite it nicely. So that is going to be equal 5 stays. So 3 comes in front, x, and we have here left 2, because 3 minus 1 is 2. And it's equal 15x squared. Next one, y is equal 2/x. So we are getting dy by dx, which is going to be 2. It's going to stay because it's a constant. And x, I'm representing x to power negative 1 and prime. Right? Because 2/x, I can write down 2 times 1/x, right? And 1/x is going to be x to negative 1. Yes? That's where from I got 2 times x to the power negative 1 prime. Let negative 1 show that it's negative 1, so prime you will see. Okay. So that means negative 2, negative 1 comes in front, x, and negative 1 minus 1 will be negative 2. And the result is going to be negative 2 and 1 over times 1/x squared, right? which means negative 2 over x squared. Okay? Next one, f of t is equal 4t squared over 5. Okay? So f prime of t is equal 4/5 comes out, right? And we will have t prime, t squared prime, right? So it's going to be 4/5 times 2 t to power 1, right? And that is going to be equal 8 over 5 t. Next, y is equal to square root of x. So y prime is going to be equal to, and x to power 1/2. This is how I represented square root prime, because square root of x is equal x to power 1/2. How? Square, we understand that it's by default is 2, and here we have 1. So 1 over 2, right? Okay. So 2 and x to power 1/2 prime. So that means, since 2 is a constant, 2 stays there, times 1/2 come in front, x, and 1/2 minus 1 is going to be negative 1/2. Okay, so 2 and 2 will cancel each other, right? And we will have, since it's negative, it will flip the fraction, x to power positive 1/2, which is going to be 1 over square root of x. Okay? Next one, y is equal 7 over 3x to power negative 2. So what I'm going to do here, I'm going to do some simplifications. I'm going to write down that is equal 7 times 3x to power positive 2, because we have negative, so once I flip, it will come on the top, right? We had 1 over 3x to power negative 2, which is going to be equal, it's flipping the fraction, 3x to power positive 2 over 1. Yes? Okay, 7 times 3x to power 2, which is going to be equal 7 times 3 squared is 9, right? X squared. So it's going to be 63x squared. Okay, now finally let's take prime. Y prime, it's going to be 63x squared prime. So 63 will come out because it's a constant. And from x squared, derivative is going to be times 2x to power 1. So it's going to be 126x. Okay? We have two more properties, rules rather saying, sum and difference rule. Oops, that's not what I meant. Sum and difference rule. Where d by dx from f of x plus g of x is equal f prime of x, meaning derivative of sum is equal sum of derivatives plus g of x. And if we have subtraction minus, here also gonna be minus. Okay, let me solve a couple of problems. It's very easy. So f of x is equal x cubed minus 4x plus 5. So from here, see each one, we have here 3 terms instead of 2. 1, 2, and 3. F of x, g of x, and then let's say this one is k of x. Okay, so derivative is going to be 3x squared minus 4, and 5 is going to be 0, right? Now, 3 comes in x cubed. Derivative of x cubed is going to be 3x squared, so this 3 comes in front, right? And will stay less 1, the exponent. 4x is 1, right? Here we have, let's see, 4x exponent is 1, so 1 will come in front, which won't do anything. 4 times 1 is 1, is 4. And then if I take 1 minus 1 will be 0, and x to power 0 is 1. So practically we have left 4 there. And the derivative of 5 is 0 anyway. As a constant. G of x, negative x to power 4 over 2 plus 3x cubed minus 2x, and we get g prime of x is equal. So what do we have here? Negative 1/2, it's going to stay. And then derivative of x to 4, it's going to be 4 times x cubed, right? And then plus derivative of 3x cubed, 3 stays. The exponent 3 come in front. And x will be to power 2, 3 minus 1. And derivative of 2x is going to be 2, which means it's going to be equal. Negative half times 4, this is 1, this is 2. It's going to be negative 2x cubed plus 9x squared minus 2. And one more example. 3x squared minus x plus 1 over x. So I'm going to simplify before I apply the sum and difference rule. It's going to be, I'm going to split this trinomial in numerator using the common denominator, which is going to be 3x squared over x minus x over x plus 1 over x. And this is going to be equal. So this will be gone. Here is x2 is going to be gone. I will have 3x only left. So here this x and x is gone, right? It's going to be only minus 1. Okay, so let me write down. We're going to have 3x minus 1 and plus 1 over x. I'm going to write down x to power negative 1. So therefore, this is equal y. Let's do this. This 3 also, I'll fix it. We are good. So from here, y prime is going to be equal. So derivative of 3x, here, this piece, right? Derivative of 3x is going to be 3. Derivative of 1 is going to be gone. And derivative of x to negative 1, it's going to be negative 1 come in front. X and negative 1 minus 1 is going to be negative 2. So which is going to be 3 minus 1 over x squared. Okay? And lastly, we do derivative of sine and cosine. I'll bring for example, and I will be done. Derivative of sine x. I'll just put sine and cosine. Sine and cosine. So, derivative of sine by x, sine x, is cosine, and derivative of cosine x is equal negative sine x. So let's apply this rule. I'll bring several short examples. Y is equal to sine x. So y prime is going to be 2 stays, right? It's a constant, and derivative of sine is cosine, so going to be 2 cosine x. Y is equal sine x over 2, which is the same thing. I can rewrite 1/2 sine x. That is going to be equal, y prime is going to be equal 1/2 cosine x, or cosine x over 2. Y is equal x plus cosine x. Y prime is equal, derivative of x is going to be 1, right? Remember? X to power 1. 1 comes in front. Here will be 1 minus 1 will be 0. X to power 0 is 1. So it will be 1 times 1. Okay? So 1 and minus sine x, derivative of sine is negative, derivative of cosine is negative sine. And lastly, cosine x minus pi over 3 sine x. Okay, so derivative is going to be cosine x minus pi over 3 sine x prime is going to be negative sine x, right? Because derivative of cosine is negative sine, minus pi over 3 is going to stay as a constant, and sine, derivative of sine x is cosine x. Okay, I'm done. And from now on, for every topic I will cover, I'm going to give you homework, a couple of problems, so you will solve it and practice it. I will give the answers. If you get the answers, that's fine. If not, please post in your comments, and I will go over the problem and solve it. Okay? Thank you for watching, and I'll see you in continuation of these rules for derivatives.